Yeah. It's a pleasure to be here with so many passionate people. I've spent the last 20 years of my life researching and sharing information linked to the links between soil health, human health, and planetary health, and I'll continue with that sharing here today. I was about 2 weeks, or 3 or 4 weeks ago actually, I was on the steps of City Hall in LA speaking to a large group of climate change activists. And following that talk, I got flooded with people, many of them asking the same question. They were asking, what was that word? And I immediately assumed that they were referring to a word that I'd used called mycorrhizal, which is really something of a spelling bee special. But to my surprise, the word they were seeking was the word humus. And for someone who is so passionate about this subject, as you'll soon learn, it was something of a shock to realise that people have become so divorced from the source of their food that they weren't even familiar with the word. And this is people who are trying to save the planet. And so we'll begin by talking about what is humus. Interestingly, if we look at the etiology of this word, we find that the words humus and human mean the same thing. They mean of and for the earth. And interestingly, the word humility means exactly the same thing. And ironically, it's our lack of humility that has seen us in our constant quest to master nature that has really brought us pretty much to the brink. So humus it's made by microorganisms, and it's the home base in which those microorganisms, these incredibly important creatures, live. Humus is the soil glue that determines whether our rivers run brown following a rain event. Humus is the soil glue that determines whether dust storms strip our thin veil of precious topsoil, as we saw in Australia a few short years ago when the Opera House turned red. Humus is the storage system for 3 incredibly important substances: carbon, water, and minerals. And it will be this trio that will have most impact on soil, plant, animal, human, and planetary health in the very near future. So I had to sort of bring myself up to speed with climate change, the latest in climate change science, prior to this presentation, and many times I actually found myself close to tears. It seems like we're now talking about irreversibility. We're talking about whether we're locked into 3, 4, 5 or 6 degrees increase in temperature. Now, someone needs to tell someone at some point that 5.5 degrees is considered beyond the levels of human adaptability. We've seen 1 degree to this point, and we've seen the massive changes associated with that. We've seen the hottest January in this region in recorded history. We've seen the worst drought in New Zealand, are still in the midst of it. We've seen Germany, the coldest March in recorded history, and that's just the start. Basically, 2 degrees isn't double 1 degree. This is something that's exponential. We don't even know what 2 degrees is going to look like. What we do know, and what I did sort of fathom from the research, is that our current focus upon cutting emissions control and cutting emissions is actually not going to save the day. Now, if we were to cut emissions tomorrow morning by 100%, which of course we're not ever going to do, but if we were, in 200 years' time, the levels of CO2 in the atmosphere drop down to the levels that we had in 1975, which unfortunately is still too warm. The oceans continue to heat, the oceans continue to acidify, and actually it's this issue of ocean acidification that is actually more serious than global warming and more urgent. And I'll explain how that works. The oceans have absorbed 50% of the man-made CO2 to this point. And lucky that they have, because we would see a hell of a lot more changes than what we're seeing currently if they hadn't. But when that ocean absorbs that CO2, it becomes carbonic acid, and it leads to ocean acidification. And we've had a 30% increase in acidification to this point. Now, the problem here is that there are some creatures that are dependent upon calcium to build their outer shell wall that struggle in increasingly acid conditions. This includes coral, it includes shellfish, it includes algae and krill, and it includes some of the phytoplankton. Now, there's a few things that you need to know here. There are 500 million people who are directly dependent upon coral reefs for their very food. Algae and krill are the basis of ocean life as we know it. Phytoplankton is responsible for 50% of the oxygen we're breathing. And 40% of those little guys we've lost already. This is serious stuff. This isn't someone else's lifetime. This is your generation, your life, your next. In fact, the research in relation to algae and krill suggests that 20 years is the time frame. So many people, when confronted with the enormity of that scenario, shut down and go back to the couch and watch sport. And what this is a call to action and trying to drive home to you that apathy has no place to play in this scenario. There is something you can do, and it's a message that I want to share with you in my remaining time. That message basically is this: there's only ever been the same number of carbon molecules on the planet, and that carbon cycles between the soil, which is by far the largest storage system, the biomass, which is all the plants on the planet, and the atmosphere. And a great deal of what used to be in the soil as humus is now in the atmosphere as CO2, thickening the blanket of greenhouse gases, heating the planet and changing the climate. So, sorry, I'll just have a quick mouthful of water here. If we want to get a perspective of how much we're talking about here, it's 476 billion tonnes that used to be in the soils now in the atmosphere. Now, everything else that we've done to contribute to that CO2 in the atmosphere, coal-fired power stations, industry, 7 billion lungs breathing CO2, that equates to 250 gigatons. So almost double the amount has come from the soil, and there's this desperate need to return this carbon back to the soil as humus. And we can all be involved in this process. This is the thing about not falling into the apathetic scenario, is that this is something we can all play a role in and need to. The first of those planet-saving strategies, we choose to buy our food from those that are practicing regenerative farming. Now, we work with farmers in 44 countries, and I can tell you one thing for certain: those practicing conventional chemical agriculture are losing humus on a yearly basis, and we're checking that with soil tests. Those that are practicing biological organic farming are building humus on a yearly basis, and of course that keeps it out of the atmosphere. We need to look after the people that are doing the right thing. Farmers markets, the rise and rises of farmers markets gives us that opportunity. We can put a face to our food, we can buy our food, research the growers we're buying our food from, and buy our food from those that are going to literally save the day. The second, just get this moving, the second of those planet-saving strategies, we need to pay carbon credits to farmers for increases in soil humuses. And this is something everyone can get involved in on a lobbying perspective with politicians. We're paying carbon credits for people to plant trees. The biggest storage by far is humus. We're talking about primary producers, food producers, the most important profession on the planet. And we'll come to realise the importance of that in the very near future. We're talking about a group of people that are struggling. You imagine, I've been a farmer in Rockhampton, 3 100-year floods in the last 4 years. They are really, really battling. We need to motivate them to do the right thing. We need to pay carbon credits to build humus, and we need to do it really quickly. Composting. So the decomposition of organic matter results in humus, and composting is where we step into the story and speed up and magnify that process. And composting needs to become the mantra for everyone. Every home gardener, every food producer, every council. Think about the deal with the councils currently. We scrape your food scrapings into your conventional rubbish. That rubbish goes onto massive tips, which have become the second largest source of methane, which is another greenhouse gas, 23 times more potent in terms of thickening that blanket than CO2. It's a huge problem, it's a huge issue, and it's easily resolved. We lobby our councils. We want a separate bin, we put our green scraps and our food waste in, and we want you to take that, and we want you to put it with the rest of the green waste in council, and we want you to compost it. And then we want to buy that compost for you to fuel that whole scenario. Something incredibly important, composting. Now that we're starting to do a lot more counts of soil life, the discovery has been really quite alarming. We find that the key creatures responsible for building humus in our soil have been absolutely decimated. The most important of those creatures is a creature called mycorrhizal fungi. So here's this little creature that burrows into the plant root, that expands out and gives you 10-fold increase in that root surface area, and this massive root extension mines minerals and takes them to the plant. It holds moisture, and it produces biochemicals that stimulate the plant's immune system so that we don't have to come in with so much chemicals control on that plant. Now, sorry, I'll just keep moving here. Mycorrhizal fungi are responsible for 30%. This is a new finding. This is a woman called Sarah Wright who discovered that this creature produces a sticky substance called glomalin. And glomalin, it turns out, is the spark for the building of humus in the soil. And we now know that this one creature is responsible for 30% of all of that humus. And we also know that we've only got 10% of this creature left. We've knocked out 90% from our soils. We can put them back. $10 a hectare it costs to re-inoculate them. We can also brew up the other cellulose-digesting, humus-forming organisms for $5 a hectare. There's something that can be done, and it needs to be done really quickly. And then we've put this workforce back in the soil. We need to legislate to protect these guys in the soil. What's knocking them around? Farm chemicals, we now know, are really harsh on these critically important humus-building organisms. We know that herbicides, or some of the herbicides, are actually more harsh on soil life than they are on plants. We know that glyphosate, the world's most widely used chemical, the new research suggests it's something of a horror show for soil life. And then we've got other things. We're over-cultivating in many instances and slicing and dicing up those fungi that build humus. And we can look at how we can manage livestock. Some of you may have seen Alan Savory's wonderful presentation from a few weeks back, now had 1 million viewers on TED, where Alan showed without the slightest trace of a doubt that you can intelligently manage large numbers of livestock and bring them in with what's called cell grazing or intentional grazing and completely change whole landscapes. In fact, reverse desertification and have a huge impact on climate change. So that's probably the other part of the equation. We're talking more humus, but this is two sides of that same story of managing soil and plants. The burning of crop residues needs to be stopped immediately. This is a food for the organisms that would have been carbon in the soil that is now going up in a massive cloud of CO2 into the atmosphere. And often you'll see these little particles up there in the ash, and that is the ash. And that ash represents the minerals. This is 5% ash from every 100 kilos that you burn. That is the minerals that grew that crop. And that mineral is now landing next door on your neighbour's farm or maybe the neighbouring town. So demineralisation and a loss of food that would have become humus doesn't make a lot of sense, and we have to stop that fairly soon. We need to put a carbon source with every nitrogen-based fertiliser. So we're talking here about nitrogen being the biggest, most widely used chemical in agriculture or mineral in agriculture. It leaches very readily. We put carbon with it, certain forms of carbon. It stabilises, so we don't have nitrates in our waterway, which are a carcinogen, and we don't have nitrogen on the reef and so forth. Nitrogen also stimulates bacteria in the soil, and this is the most abundant creature in the soil, and bacteria go into hyperdrive after a feed of nitrogen, and they consume carbon. It's actually the major way that we lost so much of our humus from the soil, was not understanding this. We need to put carbon with our fertilisers. It can be compost, it can be a material called humates. Humates are this sort of like a humus concentrate that we can extract from brown coal. And humic acid, one of those concentrates, turns out to be the most powerful known stimulant of cellulose-digesting or humus-building fungi. So it's a hugely important, indispensable humus-building tool. Now, what we're looking at here is Norfolk Island, one of my favourite places in the world. And on the left is a little workshop where we dug up a lawn, we put in some humus, we put in some vermicompost, we put in minerals, mycorrhizal fungi, mulched the area, and came back exactly 4 weeks later, and we're looking at an amazing food garden with food with forgotten flavours, increased medicinal qualities, and so forth. So we're teaching the locals how to produce their own food, as we may all have to do at some point. Finally, in this little segment, something outside of humus, and it's really been initiated by John Hewson, and in some remarkable work that he's been doing that's receiving international attention at the moment. John's argument simply is the super funds represent this massive body. Really, it represents our future and our money. And currently 55% of our super funds are invested in companies involved in non-renewable resources, the BHPs, the Woodside Petroleums and so forth. 2% of our money in our future is invested in those involved looking at renewable forms of energy. Human initiative knows no bounds if it's well funded. We can change that equation, as John's pushing for, by lobbying our super funds and having that money directed in something that's actually going to save the day. Humise does more than just offer climate change reversal. We see, for example, the National Bank saying, look, we're lending all this money for farmers to buy the neighbour's farm. The loans are falling over. We need to redefine what determines profitability in agriculture. And so they did quite a comprehensive study for 3 years. The end result surprised everyone. The determinant of profitability in agriculture was humus, was how much organic matter you had. Every 0.15% made a significant increase in your profitability. So how good is it that we pay carbon credits for farmers to increase their profitability, the most important profession that have been struggling for so long? It's a good idea. Humus is our greatest water management tool. We're talking about 3/4 of the earth covered in water, and 3% of that water is fresh. And of that 3%, 90% is used for irrigation, but it's not used very smartly. We store our water in huge dams. I'll go back here, I'm just going to get this. In huge dams with massive amounts of evaporation. We pump that water with a large carbon footprint to the farm, and we pump it out and lose more through evaporation during the irrigation process. Compare that to humus. Humus holds its own weight in water. Humus is beneath the ground, so it can't evaporate. The plant root takes it as it needs it. A 1% increase in organic matter per hectare results in 170,000 litres of water that can be stored in that soil that couldn't previously. This mat, which is 2 square metres, 34 litres, we can now store because you decided to compost your green waste and your food scraps. There's no better way to manage water than that. Humus also has a massive impact upon the nutritional value of our food. There are numerous studies now that have quantified the lots of minerals in our food. There's an argument that the food we're consuming currently contains just 20% of the nutrition found in the food consumed by our grandparents. And a large part of that is the soil. We are what we eat. What we eat comes from the soils, and the soils are a shadow of their former self. A big part of that decimation of our soil is a loss of humus. Humus is the only thing that holds all minerals. It stores all minerals in the soil, and humus is the home base for the organisms that deliver the minerals. There is a microbe behind every mineral. Humus or microbes are the bridge between the soil and the plant, literally. We build the humus, we build the nutrient density, we build the health of every one of us. Humus also reduces chemical contamination of our soils. We're seeing constantly that the higher the humus levels, the less the need for chemical intervention. We're talking about various issues in relation to the chemical contaminants on our food. Bioaccumulation, we're talking about the thing called the cocktail effect. The bottom line is our need for chemicals is based upon, a fungal disease is not a deficiency of a fungicide. We're looking at a plant that didn't have the mineral base and didn't have the microbe base to otherwise protect itself. We build the humus, we change that. Humus is also the storage system for nitrate and nitrogen. Our waters, our drinking water even, is contaminated with that carcinogen. Humus is the only thing in the soil that can store it. It's also a carbon filter, which isolates heavy metals and chemical residues and keeps them from us. It plays a huge role in soil structure. Here we see some vermicompost added here to the soil. You couldn't push a penetrometer more than this far into the soil. 6 weeks later, you can push it to its hilt. The soil can now breathe. The soil can produce nutrient-dense food with forgotten flavours and a lot more medicinal qualities. So, in conclusion, humus is literally the lifeblood of this planet, and we've used and abused this magical substance to the point that our very future is at stake. When we build humus in the soil, we reclaim carbon from the atmosphere. We increase the health of soil life, of plants and animals. We improve the management of precious water. We increase the vitality and resilience of every last one of us. We need to return to that ancient wisdom that saw the definition of humus and human as being of and for the earth. And we need to reclaim the humility to work with nature rather than this constant battle and this constant striving to master her. All of us can be involved. Lobby your super funds. Push your councils for change. Compost. Buy your food from those that are doing the right thing. and each and every one of us can help save the day with Humise. Thank you.
Thank you, Peter.